So this is what the code looks like in the final version of the Lights Out game. So the things that changed are minor, like some variables were renamed or inlined and so forth. But the idea, the spirit, is the same as what we left off in the last video. Now this time I want to show you the differences between binding variables with the keyword var and using the keywords let and const. To show you this, I want to attach some behavior to the game buttons. So here we can see that the buttons are already associated with move. But I also want to just log in the console what that position is. And I could do it by just coming here to move. And I could say console log coordinate row column. And I save, I come back here and refresh and open the console. And now when I click on a button, you can see that it logs the coordinate. So that's one way of doing it. But I want to do it in a different way. Now what I want to do is I want to attach a new kind of behavior to the button. So this is something new. We have not seen this before. The same button can have multiple callback functions associated with it. It can have multiple event listeners. I'm going to get the elements by ID the same way we do here. So I'm going to pretty much do the same thing we do here to select the button, okay? But here I don't have a board coming in. So instead I am going to iterate over a list of indices. And the same here. And there is another way of iterating in JavaScript. Instead of saying row in, I can say row off. The difference is that when I say in, I am taking the index of that element. So here, for instance, I'm taking, in this case, the index into the board, and that is a row index. Here, I don't want the row index, I want literally this element. So instead of saying in, I say off. And for this list in particular, it turns out that the element and the index are the same, so it doesn't really matter. But I want the element, so I'm going to use this somewhat new syntax of off, right? So here I am now selecting the element, and I don't want to change its style. What I want to do is say on, click, and here I want to attach some behavior to it. So this is where I'm going to do the row column thing. So I'm removing it from move, and I'm adding it to this new behavior guy. So now when I click on the button, there are two things it's going to do. First, it's going to do this guy, because that's the function that was already associated with it, but it's also going to do this bit here. Oh, and it's not really on, it's add event listener. Okay, so now let's see how this works in the browser. I'm refreshing, and I click on a button and I can see the coordinate here. Awesome. So now the button is doing two things. It's logging to the console, but also doing the request it should. And it's doing that because there are two different behaviors attached to this guy. Now let's see, here I'm using const. Let's see what happens when I use var instead. I'm refreshing, and now I click on a button and it's always saying coordinate 44. That is weird. Why is it always saying coordinate 44 instead of saying the correct coordinate for this button? Well, now it's time we have to understand what var is doing. It's actually doing two different things. First, I can have access to this row variable even after the loop. So for instance, here I can say console.log and in fact something similar to this. So when I save it, I'm going to refresh the browser here, and without clicking on anything, I can see coordinate 4, 4. And that makes sense because that was the element, the last element associated with row, and the last element associated with column. But what is weird is that we have access to these variables at this point at all, because after the loop, the variable should be gone, right? Wrong. When using the keyword var, what JavaScript is doing is called variable hoisting. So it's writing this is effectively the same as writing this. I'm declaring the variable on the top of the function body. And here I don't need to say var again. And that is why this variable is available here, because it was defined in this same function. It's still in scope. So that's the first thing that var is doing. The second thing that var is doing is more interesting. Notice what happens when this function is run. This function that is logging to the console, the one that is doing the wrong thing because it's always showing the last coordinate. Well, it's doing that because this loop is going to run really fast, just adding event listeners to the buttons. And that's it. It's going to run when the browser starts, and it's going to associate the behavior with the buttons, and it's over. And then when I click on something, then this function runs. But at that point, row is 4. We saw 4 here. So row is 4, and it's forever going to be 4. And that's why we see 4 every time. That's not what we wanted. So how can we fix this? Well, for one thing, we should be using let and const, because let and const do the same thing. It doesn't do variable hoisting, and it doesn't exhibit this weird behavior. But let and const are somewhat new, so it's interesting to see how people solved this problem before these new keywords were introduced. So let's see this. And this is not something I want you to use in your code, but it's something I want you to understand. So the only thing that introduces a new scope for the keyword var is the function. That's why the var here was hoisted to the top of this function definition. The function definition is starting here. So the only thing that introduces a new scope is a function. So what if we introduce a function? We can say, for instance, var f, this is my function, equals to a function that does this. And now I immediately want to call f, right? Because if I just define this as a function, I'm going to put it on in one line for it to be very explicit that this is a function definition. This is just a function definition. If I never call it, then I'll never see the behavior. I'll never see the coordinates being logged. So I have to call f right away. In fact, this construct was so common back then that people inlined this whole thing. So instead of saying f equals something and then calling f, people would just inline this whole definition like this. And this pattern of defining a function just because I want to introduce a new context and immediately calling it has a name. It's called the immediately invoked function expression. And in other contexts, it's also called an ADA expansion. Okay, but I'm still missing one part here, in fact. The part that is most important of all. I want to assign new names. I want to bind these names, row and column, into this new function that I created. So here I have to say row and column. And here, when I'm calling the function, I also have to say row and column. So these variables happen to have the same name, this guy here that is highlighted, this guy here, similar with column here and here. But they are not the same thing. They are, in fact, when I click on row here, for instance, you can see that IntelliJ is smart enough to recognize that this row, they are all the same one here, but this other one comes from the outer scope. So I'm calling a function that has the parameter called row with an argument that is also called row. But now because this is a function, it introduces a new scope. And because it does that, then this row will be the correct one. When we log, we will see the correct coordinate. Let's save and go back to the browser and refresh. And now we can see that the coordinates by the end of the loops are still 4, 4, and that's fine. But when I click on this guy, for instance, it shows the right coordinate. So that's a very roundabout way of defining a variable, I see, but it's good that now we have let and const, so we don't have to do things this way. It's also interesting to note that before I even had row and column here declared as variables, IntelliJ was not complaining. In fact, if I remove these guys, then the behavior is wrong now. I can refresh and show you that I'm still seeing 4, 4 every time in the console. So the behavior is wrong, but the function works, and this function works because it can access the variables row and column that were defined outside, that were defined out of this function definition. And variables that can refer to, or variables that can refer to values that are outside the function definition, that's an important thing in JavaScript, and now it's also available in Java. These guys, these functions, are sometimes called lambdas, sometimes called closures. But the idea is always that you can refer to variables that were defined outside your definition. And these variables are carried over, as we see when we click on the button. The loop finished. This whole function execution is over. The browser has finished loading. We see some coordinates being logged, and then it's doing the pooling thing. It has moved on. When we click on the button, we still can see the row and column as they existed back when this function was running, when this guy was running. And so that's what people sometimes call closures. Next, on the next video, I'm going to show you how to do some more advanced DOM manipulation that go beyond this just .inner HTML. That is a very crude way of manipulating the DOM. We are going to see some more sophisticated DOM manipulation when we look at the To-Do app.